everyone. My name is Martin, and I'm the Director of Marketing here at Evolving, and I'll be your host for this session. Okay, well, I'm happy to have on today's session Sasha Gillenson. Sasha is a founder and CEO and was the top guru in quality at Mercury and has advised numerous Fortune 500 companies on technology and process optimization. Hello, Sasha. How are you doing today?
Doing very well. It's great to be here. Thank you, Martin.
Great. So before we begin, let's welcome all the attendees and thank you for joining us. It should be very exciting. Now, let's quickly go over today's agenda. Sasha will explore why resolving incidents and problems have actually become even more difficult in cloud environments and what cloud operation teams need to do to solve them. And he'll follow that by a brief demo. Then we'll follow up with a question-answer session. We'll do our best to address all questions during the dedicated Q&A session. So, let's get started. Sasha, I'm going to hand this over to you.
Thank you, Martin. All right, so now we are ready to start. So first of all, I would like to set the stage by defining what we mean when we speak about the cloud. There are so many definitions. You speak about the private cloud, public cloud, hybrid cloud, virtual private cloud, fully automated, semi-automated. So when I will be talking about solving the incidents, I would like to speak about the cloud that has all the standard characteristics such as on-demand self-service, broad network access for cloud users, resource pooling, so reusing the resources efficiently, rapid and automatic elasticity, ability essentially to spin off additional resources on demand, and fully automated updates. So we speak about the cloud with high degree of automation and elasticity. Now, what's important to understand is that cloud typically goes hand to hand with DevOps. It's very weird, to set up the cloud environment and then to continue the usual waterfall processes. So what we see in cloud environments is that organizations are implementing agile development practices. They do automatic replication of environment configurations across the lifecycle, from the development environments through the testing to production and disaster recovery. They apply continuous building, continuous integration techniques and technologies. They do deployment automatically. They implement automatic rollback and recovery. So the cloud environment also means a different approach to development and operations. So the question is, are we actually there yet? Is it widely spread? It's widely common, this kind of cloud. Well, I would say not yet. Yes, we see this kind of environments, but we are very close. I see many of enterprise organizations investing very seriously in bringing their cloud to the level of maturity that I just described. So I believe that we'll be there soon. That's why we need to look into the process of operation, of dealing with the incidents, issues, and problems from the perspective of the cloud being, an ultimate solution, ultimate environment. Well, a lot of information that I'm sharing with you, we got from talking to our customers, talking to other vendors, to cloud providers, to organizations that have experience in cloud. So one of the things that we found that cloud is great. It brings a lot of huge benefits. Better resilience, better stability, better efficiency. But at the same time, you still see issues, when you implement cloud. So, you still can have an issue of the bottleneck. If your application is not designed correctly, you still might have performance or scalability bottlenecks that will not be solved by elasticity of the cloud. We still can have, connectivity issues due to the setup of security, due to user definitions, access, access parameters, and so on. You still can have, non-conformant data in your database. If suddenly, you have user data that your application cannot process properly, you'll have an issue that cannot be corrected or self-healed by cloud itself. You can have database performance issues due to poor database design, incorrect indexing, and other database setup and management issues. wrong or expired certificates, vulnerabilities in applications, misconfiguration of your cloud resources, of your infrastructure. I mean, very simple. You made if we speak about the infrastructure as a service, you prepare a new virtual machine template, and you patch it, for example, with the new operating system patches, and these patches are not good. And so you start to spin off new machines, you start to redeploy using the new template, and suddenly you have a problem in your environment, and it's actually a bigger problem because now the entire environment is carrying, the wrong patch. So misconfiguration still can happen. If you need to tune your infrastructure components to support specific application requirements, you standardize as much as possible, but still, in enterprise world, you can have applications that cannot live purely off the standard infrastructure components. As soon as you start tuning, misconfiguration is possible, and you need to deal with that. Now, what is interesting is that all these issues are caused by some kind of change. Being this a change in application, change in configuration, change in data, change in workload, but there will be always some kind of change that is driving this kind of issue. So we established that incidents still can happen even in cloud. So what now? On one hand, it's much easier to deal with incidents in cloud. First of all, you have a complete track of all your deployments if you properly, again, implement deployment automation. Then, cloud, again, set up correctly, will eliminate drift and unauthorized changes. Everything goes through the pipe of automatic deployments. Everything goes through the verification of automated processes. You can automatically reprovision an environment. If something happens, you can roll back to a specific checkpoint, or if you have some workload issues, you can spin off additional resources to cope with the growing or with the changing workload. However, at the same time, it's still pretty difficult to manage cloud because of the changes. First of all, you need to cut through complexity, which is increased now by an additional layer of cloud. So you have the same server stack running on top of operating system, running on top of hypervisor. Maybe even, if you do containerization, you can have containers in between, right? So on top of virtual machine, you can have containers as well. Now, under the virtual machine, you have a cloud layer, which comes with tons of configuration, with its own issues, and also with the challenge of hiding the infrastructure that is delivered as a service to you. You need to maintain stability when number and frequency of changes grows drastically. I just mentioned, that cloud is typically paired with agile development and with DevOps, with deployment automation. That means that number and frequency of changes is increasing drastically. And every change, however well it's planned and reviewed and tested, it introduces some kind of risk. So more changes, more risk. And what's interesting, what we see is that the success rate of changes increases very significantly. So you can have, in the past, we saw organizations that will do, a weekly build, a weekly release, and they will have 10% of failures, right? Now they have an hourly deployment, and they will have 99.9% success rate of the changes. But if you look at the overall amount of changes, you still have the same or even larger amount of incidents, just because of the fact that even the more successful changes can introduce risk and can fail. Now, if you get to the point that you need to involve a cloud provider, it could be quite a challenging step, because then you need to argue to prove that the provider owns the issue. It's not the changes, application updates, or whatever you did to the infrastructure configuration that created an issue. I mentioned that rolling back to a specific checkpoint makes it easier to manage cloud, and that's true, but you need to know where to roll back to. Like, the changes can have delayed impact. It's not necessarily that last deployment created an issue. Let's say that you introduced an application change 3 releases back, and now it manifests itself because you have a significant amount of data that the old update cannot cope with. So now you need to understand that you actually need to roll back 3 versions back. And so finding this point where you need to roll back to is not so easy. Now, not always rollback is possible or economical. Just another example, I mentioned this three versions, 3 releases back. Can we actually roll back and disable features that our users became used to and rely on? Let's say that our database schema, database data model changed, in between the releases, and we already aggregated new data. Can we actually convert data back into the old format? We also need to resolve problems causing incidents even after the incident recovery. Let's say that we did the rollback, it was very fast, we recovered from the incident. But what about the problem causing this incident? What if this incident will happen again in a few hours? We cannot just roll back. We cannot just reboot. We need to understand what was the problem, what was the root cause driving this incident, and we need to address it before the incident manifests itself again after the first time it was recovered. So the problem resolution becomes even more complicated because you start to investigate the problem in the environment that already changed. I had an incident, now I actually resolve this incident, I recovered from the incident, so I don't see any incidents. There is any evidence other than some records in the logs. So what actually created the problem? I need to reverse engineer this without actually following the entire state of environment. So the big problem is that the cloud incident management cannot rely on rollback only. We cannot say that now we have rollback, so that's it, the problem of incident solved. Not always rollback can be used. You need to know where to roll back to, and you actually need to solve the problem behind the incident anyway. So how can we close the loop of cloud automation addressing the incidents? Again, we address, we automated building our applications, we automated building our infrastructure, we automated deployment of the changes. So how can we automate the process of dealing with the incidents and problems? So first, we need to accept that change is a root of all evil, that still numerous cloud issues are caused by changes. And when I speak about the changes, again, it could be changes anywhere. It could be changes in application, configuration, data, workload, and other aspects of the environment. You need to know the changes to decide where to roll back to. You really need to understand which change caused the problem so that you can roll back this change. You also need to know the changes to resolve problems. As I said, you need to know the history, which changes led to the problem. Because, without knowing this history, we cannot really resolve the problem as our environment was already updated, it was recovered, so we don't see any evidence of the incident. So in order to address these changes, these bad changes in the cloud or changes causing problems in the cloud, we need a specific set of capabilities. First, we need to have a complete visibility into actual changes, not the ones that we plan to deploy, not the ones that we assume that we deployed, but the actual changes that were deployed, that happened, and now are in our environment. We need to know those changes. We need to know their history. We need to have complete visibility into the current and historical state of the cloud environments, not just knowing about the changes, but what is the state, what is the configuration, what are the active servers, what are the active containers, what servers, virtual servers were active 2 hours ago, a day ago, what was their configuration, what was the state of the workloads then. We need to have all this information about the environment. We need to be able to automatically correlate changes to incident. There are so many changes. We just mentioned, we are in agile development, mode. We are in continuous integration and continuous deployment mode. We have so many changes that without automatic correlation, we will not be able to know which of the changes to deal with when we are addressing the problems and incidents. And we need to automate, part of, on top of correlation, we need to automate risk analysis. We need to know which of these changes are important. Again, in this sea of data, we need to automatically find the data we care about, both when we investigate an issue and both when we are proactive. Before we have an issue, before we can correlate a change to an incident, it's better to know proactively that the change can cause incidents in the future. And the only way to deal with that is to assess future risk of a change. Unfortunately, if you look at the existing IT tool set, cloud management tools, virtualization management tools, IT management tools, deployment automation, all these tools lack these capabilities. And it's very difficult to build these capabilities in-house, to build the analytics part, the correlation part, the complete collection of the data part. That's quite a project that is typically not a core competence of the enterprise IT. Before I move on, I really would like, to mention the current state of affairs. I started with setting a stage and telling that the cloud, the ultimate cloud is really great. It's all service, elasticity, fully automated updates. But to get to this stage, you need to do quite a bit. You need to standardize your infrastructure. If you are, a regular traditional enterprise organization, you need to develop new cloud-native applications, or you need to refactor existing or re-architecture your existing applications. You need to accelerate your changes. You need to move this to agile development, again, to leverage the full benefit of cloud. You need to automate your processes. You need to automate deployments. You need to change your process and your culture. I mean, you can't do any manual updates anymore. Again, there is the operations are changing. You cannot go and log into server and fix a problem. You do it in a different way. You don't touch the servers. So like basic operational activities are changing. And so that requires people mindset to change, people culture to change, and processes to support that. So the bottom line is it's really not a piece of cake to migrate from a traditional data center to cloud. Migration takes time. It typically is done incrementally. You typically need, start with a set of applications. You standardize certain elements, like operating system level, database level, and so on. That's where you start. You implement part of the automatic processes, and so you make a step, you succeed, and you continue to to make additional steps. While you are doing this, you need to deal with the kind of old challenges coming from old, not fully converted processes. The recovery is not so easy when you don't have fully automated rollback, right? When the rollback is less accessible. Once you didn't standardize your infrastructure, you didn't standardize your automation, you didn't implement all your automation, drift and unauthorized changes will exist. You need to deal with them. And because the server instances could be different one from another, all this time you don't have a standard set of server instances provided to all the users within the organization. You need to have a detailed knowledge of each instance configuration and state. So it says that knowing what changed is important when you are managing ultimate cloud. Knowing what changed is really critical during the migration process while you are moving from your traditional environment to the ultimate cloud. So how evolving technology can help to address these challenges? The challenge of managing the ultimate cloud and the challenge of migrating to the cloud. So first of all, a bit of background on Evolving. We are providing our solution to enterprise organizations, mid-size and very large ones, for 9 years. You can see the list of our customers, and these customers are successfully running our technology in their production environments, in their traditional data centers and virtual environments, and in cloud. The space that we are in, IT operation analytics, that's the part that's actually helping to address the cloud challenges. This space is now well covered by such analysts as Gartner, EMA, Forrester. All of them know very well about Evolving. We even were selected as a cool vendor by Gartner in 2013. So any independent perspective could be obtained from the analysts. We have a number of technology partnerships in the traditional world of system management, as well as virtualization management and cloud management world. But where do we come? To remind you, we just talked about missing capabilities that we need to address changes in the cloud. It's visibility into actual changes, visibility into the state of the environment, correlation of changes to incidents, and risk analysis. And that's what Evolving does. Now, first of all, we collect information about the changes and differences across environment, end-to-end environment, again, from physical infrastructure to virtual to cloud. We can also use additional information coming from existing IT management or cloud management tools. both contextual information like change requests, incidents, deployment information coming from service desk and deployment tools, as well as symptom information coming from monitoring tools like APM, from log management tools, from network management tools. That's not necessary. We can rely and we can base our analysis only on information that we collect on our own, on changes and differences information. But if additional information is available, we can blend it in and we can increase the depth of our insights. All this information is passed through the analytics engine, and analytics are using machine learning, anomaly detection, knowledge base, multi-dimensional risk analysis to answer 3 key questions. The first question, what actually changed in the environment? What is different in the environment? Again, not what was planned, what we think was changed in the environment. What actually changed? What is the latest state? How is it different from the previous state? Now, once we have information, when we can answer the first question, the next question will be, okay, if we have an incident, which change is the root cause of this incident? How do we link the changes to the incident? And if we don't have incident yet, then which of the changes can cause future issues? So by assessing risk of any actual change that we detect, we can predict essentially, we can point to the changes that can create future stability, performance, availability issues. The data collection is a very essential one. And here it's a very busy slide, but it's important for me to show you the depth and breadth of the information that Evolvent collects in order to make this change analytics possible. So we look through the entire server stack, virtualization layer, cloud layer, and infrastructure in private cloud, all the different components, and we pull information from files, registry, databases, data in the databases, system commands, API calls, any possible source of information, source of changes, as well, as I mentioned, we can import data from the existing tools when they are available. Now, we also break down this information to the most granular level. If it's the configuration information, we'll parse configuration files, and we'll get down to individual parameters. We'll be able to say, this parameter changed from this value to that value. This schema element changed from this value to this value. This attribute of the schema changed this way. Here is a change in the store procedure, in this line of store procedure. If it's a master data, here is a field, data field, that changed from this value to that value. And we extract, these components, this granularity in each of the layers. In cloud, we'll look into the details of the security groups, of accounts, of routing tables, for example, network interfaces, virtual instances, images, properties, and attributes, storage configuration, and so on, and so on, and so on. Now, that's a lot of information, and that was my point. You can't really deal with this information without automated analytics. And that's what Evolvent does. On top of the collected data, on top of the external data, if it's available, we put the analytics layer that automatically cleans the data, correlates the changes with any available external data if such exists, like change requests, like performance alerts, and then we calculate risks for each change based on various dimensions, various algorithms, each algorithm assessing some kind of risk aspect of the change. Each risk dimension represents a machine learning, a statistic, or heuristic algorithm. We also use an out-of-the-box knowledge base, which is based on subject matter experts' input to provide information about the impact of the changes. Obviously, all these models, all these parameters, including knowledge base, are customizable, but the system works out of the box. You don't really need to do anything. You essentially drop Evolvent, it collects information, it starts to analyze this information to generate insights about the changes and difference that we see in the environment. And on the slide, you see examples of these algorithms, like value anomaly. We look for the patterns in value changes. And for example, if you have a particular configuration parameters that was changed to 1,000, while typically it changes in the range from 1 to 100, we can say it's an anomaly. It's suddenly, we never saw it before, and it's really different from what happens in the environment. So we will increase the risk of this change, saying that potentially, maybe it's a notch closer to causing an issue. And we look at the time of the change. Let's say if typically you implement your infrastructure updates, your infrastructure tuning is done at midnight. So if we suddenly see it happening at noon, we can assume that it's either emergency page or something was broken. So again, the risk is higher. So combination of all these different algorithms and factors creates this probability of a change being a root cause of an incident or causing a future issue. And using this technology, we can definitely help to drive smoother cloud operations. Here you can see a number of examples where we can help actually to address a specific cloud issues. Like for example, you have a system that is deployed on Amazon Cloud and it experiences a network performance issues. So what Evolvent will do, it will assess changes over time, looking for the changes that may affect performance, that have the highest probability to affect performance to create this network performance issue. We'll look at how these changes are applied across environments and what is their risk. So applying the analytics over time and across environments. And then our analytics recognize, for example, that there was a one-time, like really large-scale change that implemented a lot of rules, firewall rules, such that only problematic instance has these rules applied. So then we look at there is only one outstanding and in fact impactful change that has a high risk. So we highlight it as a root cause by applying a number of security rules to an instance. So that's like, we definitely take, a specific, out of the set of changes, we find one change that looks the most probable as a cause for a particular type of the incident, and we highlight this change. And similarly, like, examples of issue we can help, let's say a slowdown of application using Amazon Redshift, high CPU utilization shortly after Windows is started in virtual server. All this like real examples that happen with our customers. And in each of them, this ability to detect the state of the system, all the changes, and prioritize them and correlate them to the type of the problem, help to identify very quickly what the problem root cause is. So what are the key takeaways? One, that I mentioned cloud brings resilience. Cloud is great, but issues will happen in spite of all the capabilities of the cloud. Just a different type of the issues. But most of the issues still will be driven by some kind of change. And to manage effectively incidents and problems in the cloud, you need to have a complete visibility into these actual changes in their history, into the actual and historical state of the cloud environment. You need to be able to correlate all the changes, all this amount of changes to the incidents, and you need to be able to prioritize the changes based on the risk to know how to prevent incidents, not just how to respond to them. And our analytics, our change analytics specifically targets this question, the question of what changed, which of the changes is the root cause, which of the changes can cause a trouble. We collect data in depth across the entire cloud stack. We detect application, configuration, data, workload, and other types of the changes, and then we apply machine learning risk analytics to answer these key questions. So switching to a quick demo just to show you what Evolvent can do. Right now, we are looking at a web-based console of Evolvent as the inventory of the product, where we keep all the collected information about the configuration and state of the environment. We can see here that we have an Amazon, essentially an Amazon setup with a number of different instances. And just to show you all the different layers of the information we're collecting. For the Amazon itself, we'll collect information about the Amazon account properties, about routing tables configuration of this account, and down to individual parameters. We'll go and collect, look at the configuration of the instances. And you see instances properties. We'll see the image information, the details of the images used to spin off AMI, spin off a particular virtual server. We'll see also for each virtual server, we'll see also the components running on top of the server. So for example, we see here in this environment a server by name IPAC1 and so on. We see that it's running Citrix, it's running Evolvent component, IIS, it's running on top of Windows, and there is also Tomcat. And for each of these components, we'll have the same depths of configuration collected, and so that we'll see configuration of Windows, just showing it quickly. All the parameters, again, down to the individual parameters, all the files, all the registered DLLs and so on, configuration of IIS, websites, web applications, and so on. So what can we do with all this data? One thing, we can be proactive. So right now I switch to the dashboard that shows me a business service running on cloud called On-Demand Loans, and I see that there is almost 800 of changes that happened, on particular date. I can also see that there are only 10 high-risk changes recognized by Evolve Analytics. So I want to jump quickly and see what are these changes. And I can see that they are distributed. They are actually sitting within, the virtual servers. My cloud infrastructure is fine. It's just, the database, the application servers, and some changes in operating systems. So why are they high risk? I actually can look and see what what insights my analytics is providing. And we say that actually we had a transaction performance alert caused by high-risk non-compliant changes. We also see that there was a change request that resulted in some changes that were identified as suspicious due to their nature. So the next step here, we can actually go and see the changes themselves. Let's pick up the changes. And we'll see what kind of changes, what actually the change was. And eventually I jump to the Tomcat changes, and we see that a particular connector in Tomcat had a parameter compression turned on. So we can see actually why this is a high-risk change. We can see the reason that it is such a high risk is because it's a non-compliant change. So at this point, we can actually open a ticket, start automatic remediation using tools like Puppet, Shift, or any other provisioning and remediation tools that you are using in your cloud environment, or share this information with a relevant DevOps or Ops specialist so that they will take care of this particular high-risk change. So with that, being conscious of the time, Martin, do we still have time for a few questions?
Absolutely. Okay, so let's open the floor. I see we already have a few questions here. Isn't cloud itself supposed to reduce the amount of costly incidents?
So that's actually a fair question, but as it's exactly what I mentioned, that cloud does reduce the amount of incidents such as, incidents caused by drift, incidents caused by unauthorized change, manual mistakes, fat finger mistakes, but it does introduce a new kind of incidents. So the answer is yes, it reduces some kind of incidents, but it introduces a new ones.
Okay, is Evolvin predictive? Could I use Evolvin to prevent issues?
And that's an excellent question. Absolutely. The risk analytics that I was talking about and the essentially use case that I was showing is all about the prediction. There is no incident, there is no problem yet, but Evolvin looks at the changes that happened, assesses the risk or a probability of them to cause future issues. So essentially, you can deal with the problem before it happened. If you see that this change was deployed wrong way, had wrong value, was executed not as planned, all this can trigger a remediation action on this change that will prevent or save us from the future incident.
Okay, we're running short on time, so we got one more question we can fit in. Can incidents just be solved by a rollback or reprovisioning?
So a lot of incidents can be solved this way, and then, as I mentioned, still, even if the incidents are solved that way, you still need to know where to roll back to, and you need to solve the problem that caused the incident. So it will be, you recover from the incident, you still need to solve the problem. On top of that, not every incident, could be solved by the rollback. What about the situation, as I mentioned, if you change your database schema and now you aggregated so much data that you can't really roll it back, without losing some valuable attributes of this data? What about the key capabilities that your users are already used to, and the rollback will actually eliminate these capabilities? So not always rollbacks are possible, but they are a powerful tool. But even when they are a powerful tool, you still need to solve the problem that caused the incident that you rolled back.
So I'd like to thank you all for taking the time to join us for this session. I personally found this to be very interesting. Also, I'd like to hear from people who attended our session, so feel free to drop me a line with any questions or feedback, or you can contact us to schedule a discussion or even a live demo. So on behalf of our team, I want to thank you all for taking the time to join us today. We'll be sending you a copy of this presentation and the recording. And do you want to learn more? Visit our website and check out the resource section with many more videos and presentations. Once again, thank you, Sasha.
Thank you, Martin, for the opportunity to be here.